Afternoon, folks. Here's a sculpture. Like it's a proper sculpture day. This is the kind of day where it separates the men from the boys. If you run for shelter and you run for the AC, then of course you're scared of man-made climate change. But if you stay out in the sun and enjoy yourself and acclimatise to the planet, all is good. Right, let's have a quick look at some absolute light. See that light over there? Flashing? Flash, 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 flash. I'm doing it right here. I'll zoom out. I've got this mirror here. Right, so that mirror, I've got the sunlight bouncing off of it down to here. That mirror bounces to that mirror way down yonder. And then that mirror, if you look carefully, you can see the other mirror where it's going to round that side of the house. And then from that corner of the house, it bounces the light to that mirror and it finally comes to us. So we have the sun and this mirror right here. Here. I do that. As you can see, that one tap, right? I'll tap it from underneath. Tap, 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 tap. Now, what we are seeing is absolute light. A mirror with a diameter of, say, 10 to 12 centimeters will bounce the sun's light over 120, 130 miles, but like that. Now, this mirror, we're looking at 125 to 140 miles or something, I think it is, right? Now, as you can see, when you see that light, if we had somebody at 1 mile, 2 miles, 3 miles, all the way up to 140, let's say 150, right? So about the 140s people, no, I can't see it if it's, I'm out of range, obviously. But all of those people that are in range will see the light at the exact same time. I'm now going to send the light down to this mirror down there, and you should see it over there. Should do. So we go again. I've only got one set of hands and one eye. No, I get the wrong angle there. But this one, right? What's happened is we need to go up because the sun is going over the horizon. Not over the horizon yet, but the fence and all. You know what I mean? So, like I was saying, absolute light. There is no delay. If wherever that mirror is going to bounce, it bounces at absolute speed. If you have a bigger mirror, like the ones that we're looking at, the big ones, right? That one, now that one is going to bounce its light way more than the 12 centimeter one, isn't it? But the thing is, it's going to bounce its light at absolute speed to as far as it's going to go again. There is never going to come a time where a light source is out of range from somebody and the light has to travel after the event itself after the switching on. Now again, all I'm doing, I'm touching, let me just get over here so I can make sure I see what's happening. Right, I tap this mirror here. Right. Again, there will be no travelling of this light. Anybody who is going to see this light, right, will see it at absolute speed. See that? There will never ever come a time when light has to travel towards somebody after the onset, because that initial blast of light is always going to be absolute light. And the more powerful and bigger the light source is, the further that light is going to radiate. Right, let me go and turn that round. Let me go and turn that mirror around. Don't mess about. So, what we are seeing is the sun after bouncing off of 1, 2, 3, 4 mirrors. We're not seeing a parade of photons, right? We are seeing the sun's reflection in the mirror. And it's so fast. So, if I tap this mirror here, where it's the actual sun, the first mirror, look. Let me put my hands in front of it. That's me trying to get in front of it, but it's big enough that it's kind of surrounding my legs. It's doing that, not time dilation. What's the other absurdity? When it bends light. No, that's gravity, isn't it? I think I'm gonna have to, if I go, what this is about. All right, let's stop talking about bending gravity. What you're seeing here is the absolute light from the sun. There is no delay whatsoever. That flash, that is absolute light. Bang! Doesn't matter how far a person is. When you bounce the sun's light or any other light towards somebody with a mirror, it is going to reach the furthest it will reach at the very same time as it reaches the first person. If we have everybody on a mile marker, what with that mirror in front of us over there, look, the little one does 120, say 130, 140 miles. That mirror over there is 10 times as big. That mirror over there is doing 1,000 miles. I would bet my life easily that mirror we're looking at over there bounces the sun's light 1,000 miles. Now, that 1,000 miles, you have somebody at mile 1, 2, 3, 4, all the way up into 1,000. When you bounce that light, every single person sees the flash at the very same time. The person who is right next to that first mirror, where the sun is bouncing off of, to 1,000 miles away. The person who can see it, but he's just out of range, and then there's a few other people behind him, further away, they cannot see the light. That person, that very last person who can see that bounce, is going to see it at the very, very, very same time as the first person on mile marker 1. Then what do? Then we go for a mirror 5 times the size as the one we're looking at. that 1,000 miles easily becomes 5,000 miles. My life on it. You get a mirror 5 times the size of that one, it will bounce easily 5,000 miles. And we do the same thing again. You put somebody on mile 1, 2, 3, all the way up to 5,000. Go up to 6,000 just to catch the last stragglers who some can and some can't. The person at 5,000 miles would see that light bounce off of the mirror. He would see that light source kind of from where it was bouncing. He will see, he's looking towards the mirror, and he will see that. He will see the flash when the guy 5,000 miles away bounces the sun's light towards them. From mile 1 until the very furthest, mile 5,000, they would see this, bang, at the same time, this, bang. There would be no difference. The only difference there would be from the first until the very last is it would be a little tiny bit dimmer all the way along the line. You wouldn't notice it from miles 1 to 5 and 5 to 10, but from 1 to 20 and 20 to 40, 20 to 60, that kind of a thing, there would be a little bit of dimming, but no speed difference. It's absolute speed. Then let's say, for example, that mirror, 5 times the size as that, we go 20 times. So all of a sudden we have a mirror the size of the side of a house. We go from 5 to 100,000 Ks, just under a third of the distance to the moon, right? A mirror the side of a house, your average house. That mirror, that house, that side of the house will now radiate its light 100,000 miles. I put my life savings on it. You put mirrors on the side of any house, like 4 meters by 4 meters, that kind of a thing, we are looking at 100,000 miles, like that. Bang! And once again, you put somebody at mile 1, right next to the mirror, right next to the side of the house, and you have people, 1, 2, 3, 4, 1,000, 2,000, 50,000, all the way up. One person, every single mile marker, up to that very last distance, the furthest distance that light will radiate, and that very last person, that 100 and whatever thousand miles away from the side of the house that is a mirror, will bang, bang, see it at the very, very same time that the person who is leaning against the side of the house will see. There is no delay. It's absolute light. It is not logical. It's very, very illogical to think that there would be a time, a situation where somebody was out of range of a light source, but the light source was traveling towards them like they tell us it does. It doesn't. If you can see a light source in the night sky, you are seeing it because it is powerful enough. And everybody between you and that light source, whether it is 50 miles or 50 million kilometers, you will see that light at the very same time. If it's switched off, it goes out for everybody. It turns back on, you all see it again at absolute speed. I mean, look at that, look. And for those of you that probably, I just can hear them in the background going, prove it. That doesn't prove anything. Just because it's flashing, like, pretty impressively actually, but that doesn't mean anything. It actually does. That right there is absolute light. We're not seeing photons that have bounced onto the mirror that I'm holding, that I'm shaking. That one, right? That's bounced onto that one down there near the gate, to the other one on the other side of the house, back to that one that's now starting to shake in the wind, and then to your eyes, photons, absolute horseradish photons. Invisible, massless packets of nonsense is what they are. They really are. What you're seeing is absolute light right here. Bang! That is the sun in the sky. That right there. If the sun goes out now, bang! We are all plunged into this darkness. Das Web of this darkness, yeah? That, ladies and gentlemen, is my star, and it radiates absolute light. I hope this little tiny, well, it is kind of, I like to think this is educational. You're actually seeing stuff. You're not just hearing about it in the classroom and it be theoretical. And he who remembers most of the absurdities, he who remembers all of the equations, the nonsensical equations, is the cleverest one. But when it comes down to the practical, when it comes down to actually trying to time the eclipse of Io and Jupiter, then it's a different ball game altogether, isn't it, folks? Because that is an absurdity that we're going to give it a whole lesson. What we're seeing here, guys, this flash, right, is the absolute light from the sun. You saw what the little mirror was like. Let me take this little baby over there. I'll take both of them. Oh. I'm nursing an injured foot. Fucking piece of glass in there. It's been in there for months. And every now and again I step and it goes, oh! And I tried digging it out earlier. Oh. 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 100, 120, 130, 140 miles. 100, close to 200 kilometers, right? Harvey Bay. From here to Harvey Bay. Bang! There's one person every single kilometer from here to Harvey Bay in the line of sight of this, and I go like that to Harvey Bay, bang, in that direction. Everybody sees it at the exact same time. You can see why, can't you? It's not like the guy at the end is going to be waiting for that flash. So it's way, mate. Go get yourself a coffee. How about 8 minutes and 20 seconds? Still 8 minutes. Concept of finite light travelling in packets, finite, it's illogical. Belongs in the twilight zone. You can see what this light is like. You will not get more powerful light than the light of the sun. It is the ultimate when it comes to light. No, China did not make a sun that was 50,000 times hotter than the real sun or something stupid in a lab. It's the things that they say. Scientists have discovered. Scientists are alarmed. Scientists are in awe. Can you not see that they're just words? Words that you fall for. When you read something that says, latest study by scientists makes us question our common sense. That's what you need to hear. So the lies that you're being told. Liars and charlatans. People claiming knowledge that cannot be known. Once you talk people into a finite light and Mickey Mouse packets of invisible massless photons, right? You also are saying that you know what is going on, that you know how light travels or at what speed it travels, and therefore you know how far away the stars are, and therefore you can work out the age of the universe, because light is finite and it is traveling at a certain speed. And you can also pretend to go to other planets because there is a delay. You don't have to do anything at absolute speed, because if you did, you'd be pretty much screwed. These are the big ones, right? That is why the push for relativity started. They need finite light. They need the buffer. They need the buffer between communications. They need the buffer between... Listen, I think you'll find out that everything is going to behave like light. I'm talking like radios. If you're in range, right, of a radio, then you can talk. You can receive messages and you can send messages, right? If you're out of range, you're out of range. The end. Somebody can't, like, they keep. I say it defies common sense that they're talking to Mars 15-minute delay, right? For me, the whole Mars is obviously a no-go, because I know they didn't go to the moon. Do you know how? Because I know Apollo 10 did not go up there and mess about with thrust in a vacuum, drop to within 9 Ks of the moon, take some photographs, and then zip back up to the freaking command capsule. And then, guess what? Perfect re-entry. That was in May 1969. 2 months later, cheers for the photographs, guys. Off we go. And then nil and buzz. It didn't happen, guys. It didn't happen. Defies common sense. When you know one didn't go, listen. It's like dominoes. If one didn't go, the next one didn't go. They piggyback each other. If Galileo didn't, leave Galileo out of it. If Roma didn't, and anybody who is starting to round their common sense up will know that Roma could not have. He did not have any accurate timekeeping devices. There is no delay, and we know that because of our solar eclipses. So straight away, look, the evidence never denied anybody. It is people who are denying the obvious evidence, because you cannot be objective. You are subjective, and you just have to stick with what you've been taught, even though it's wrong. Intelligence is changing your views, changing your belief system as new evidence arises. If you don't change what you believe in, when new evidence that really should be changing what you believe in arrives, that is not really very clever, is it? It's a lack of common sense, being stuck in one's ways, just what the system ordered. People are taught cognitive dissonance, taught to get the shits and to argue anything but changing their mind on the absurdity of their country, I guess, in this case. See that? Absolute light. See that? Alright folks, we are coming up to, 25, I think it was on 29. Let's go get a drink of water, I'll be right back. Come on, let's do a quick rainbow. You've got time. Come on. Hot, it's like boiling water. Help! Alright. What are we on? 26, so I could get a couple of rainbows out of here. So what would you like? Multicoloured? How do you like the rainbows? I can't see it yet. That's the right I mean. Oh yeah, there we go. So what do we think is happening here? That the sun has all of the colours of the rainbow in it. And you should see a double there. See a double? And there's so much light here. I'm not even sure that you're seeing it. Oh, there you are. It is said that the sun's light has all of the colours in it. The white light, when it hits a prism, God knows where, what's his name, got one in the 1600s, Newton. Anyway, I'll let it go for another day. Probably the same shot where Picto got the beam of light in 1849. There you go. Maybe these people shopped in the same place. There's something to look into. Is there ever any reports of a shop from the future? Can somebody look it up? Of course, you haven't got any books and it won't be in Google. They would have taken it out by now. Now, it was said that the white light contains all of the colours and they split when a prism is introduced, or like this. But I feel it's going to be a lot simpler. I think this is just a normal reaction between light and something like transparent water, a glass prism. It's just a reaction, a fairly natural reaction. I don't think we can lay down a century's worth of science on this rainbow. I think you'll find it's just light and moisture. It's just a reaction. But no, the same as that's what I can't go into it. So I hope you are seeing these rainbows. I think you are. The light is blinding me. I cannot see. And I'm going on a hunch here. Well, I can see it and I can see where you are, so I must see it. Alright folks, coming up to the end now. Remember, it's going to be a hot summer. The idea is to enjoy the sun. You don't hide from the sun. You enjoy it. You acclimatise to the cloud. And then, it's never too hot. And when it gets cold, you use blankets. You don't put heaters on. AC and heaters and make people stop. Make people run from building to building. Oh, the sun, the sun. Sun's good for you. Get out and enjoy it. Don't hide from it. Don't tell people to hide from it. Makes them weak. Makes them soft. Look at this generation up now. The one that we've got now. Soft! soft in the middle, they're soft outside, they're like fucking jelly beans. All right, later, Pete.